All right. So let's start with the lecture, and I hope you have watched the concept and fundamental of neural network from the previous lecture, and today we're gonna learn on hands-on material on the neural network, and we're gonna do some use case project here, some small project. The project is called exclusive OR operation. This is a very simple project basically. This is the best way to understand the neural network. In other words, you can say this project is about exclusive, or probably you can have XOR recognition system. Okay, you can say that this one XOR recognition. Okay, that is another word. The same similar term as face recognition, but face recognition is to recognize face. Object recognition is to recognize object. Food recognition is just to recognition food. Rice food recognition to recognize type of rice food, and XOR recognition is to recognize XOR. So they are all the similar term. Okay, just the domain a bit different. Okay, let's look on this one. Basically, the first thing when we have this topic, the first thing we're gonna do is look at the problem statement. Okay, so this is the most important thing. The context of problem of our topic. So here we have, so in this problem statement, basically, what we have is XOR kind of thing. So this is the XOR. Okay, we took a simplest thing here. So in this is called a data set basically. And we have X1 and X2 as the input. If you put input 0 and 0, the output will be 0. If you put 0 and 1, the output will be 1. If you put 1 and 0, the output will be 1. And if you put 1 and 1, the output will be 0. So left and right is quite important here. If you have put 0 on your left and on your right is 1, then the output is 1. So this is the factual thing, the data that we need. In other call is we call it a data set. And so we're going to have a develop the model that can predict XOR when 2 binary digit as the input. So the purpose here is XOR recognition. If we put 0 and 0 as the input, what are the model going to predict? So in this case, the model should be predict which is 0. The output will be 0. Okay. And if the input is 0 and 1, what are the model going to predict? Okay, so the model going to predict, in this case, is supposed to be predict number 1. And if you put 1 and 1, so what are supposed to be the model going to predict? In this case, we hope after the model has been trained sufficiently, the model going to predict is 0, and so on. Okay, so we're going to develop the model that recognize the OR operation here. Okay. And so this is the problem statement. Okay, just like this, the same thing. 2 binary digit as the input, either 0 or 1, and the output will be predicted. Okay, and then we'll look later how the prediction, it is accurate or not accurate. And for this prediction, we need to develop a model. So this model gonna be trained sufficiently to predict this one. Okay, and this is called a data set. Okay, in this case, the data set is a numerical. Okay, text data, 0 and numbers. Okay, so the design basically, what we're gonna do is we're gonna develop a model that can predict when to be as the input. So in this case, so the target value is supposed to be 0 and 1. Okay, So target value here basically mean label. I hope you remember the term target value on the previous lecture. So target value here basically is a label. So in this case, we got label, two label here, two classes, whether it's 0 or 1. And it call a binary classification because it's only got two choices. So we're gonna classify only two things, two classes, 0 or 1. Or in other words, if we move further on, we can either class COVID or not COVID, cat or dog. Okay. And if you got multiplication classification, you got so many. You got kerabu, nasi dagang, and so on. But in this case, we consider only two. Okay, either cat or not cat, either animal or not animal, either dog or not dog, cat or dog. So that's the binary classification. And the input data basically. So we have to clear the problem statement. The input data basically that we're gonna train, this is called a data set. It's only got 4 data here, 0, 0, 1, and 1, 0. And the label only got 2 label here, 0 and 1. Okay. And so let's move to the design. Okay. So these are the things that we need to think about. What are the input form? What are the label? So how many layer you gonna do? 1 layer, 2 layer, 3 layer, up to you. And how many neuron you gonna put in 1 layer? Neuron, 5 neuron, 10 neuron, 1,000 neuron. It's up to us. Okay. And what type of activation function we gonna use? ReLU, sigmoid, and so on. So we got an optimizer that for propagation. Okay, forward, backward, and many time in epoch. So what we're gonna use? Random optimizer, and so on. And how many bias do we gonna set? And this is depend on how many neuron you got and how many weight. So this depends on how many layer and neuron. Okay. So we're gonna first the design. After we clear the problem statement, we're gonna design. So this is what I'm going to design. All right. I'm gonna put 1 layer. All right. It's my choice. I just give one. Let's say we have 1 layer, only 1 layer, and I decide that this layer I'm gonna put 5 neuron. And the input basically I have 2 because I have 0 and 0, x1 and x2. So I just put input. Okay. And the first layer I put only 1 layer and consists of 5 neuron. And the output here I put it 1. Okay, 0 or 1. Or you can have another one here, also can. So this is 0 and this is 1. Also can. Okay. So, all right then. For this one, basically, let's see. Okay, for this one, all right. And before we move this one, I'm gonna move to the. So we move to the hands-on material. I'm gonna show you. So this is the code basically. You can have the code from the eLearn. I put a PDF there. Just can copy paste and put open your Google Collaboratory. This is a Google Collaboratory. And once you open this one, just as usual, get connected. Okay. And let's wait while it get connected. Okay, now we are connected to the cloud, Google Cloud somewhere. And so this is the code that I'm gonna do on this problem. Okay, on this problem. And so let's first, I think I'm gonna clear the output first. Okay, so we have no output. And just my habit, I'm gonna check what is we're gonna use a TensorFlow here. Okay, so my habit, I'm always checking what the version are now because the version keep changing. When I do it this code, basically I think 2 years back or something like that, okay, as my tutorial. And then now I think the TensorFlow is been improved, just like Python, 2.8, 2.9, 3.0. So we're gonna check the version first. So it is 2.8, okay. And never mind, we just proceed, okay. And first of all, so we're gonna have 2.8, okay. So previously I'm using 1.13.1, okay. When I develop this code, I'm using the TensorFlow version 1.13.1. So now is upgrade to 2.8. So hopefully 2.8 can work on the previous version. Okay, let's see. So the first thing I want you to know is the tree term here. Before we move further on the neural network modeling design, I'm going to introduce to you three main important things. Okay, and this version we're going to look in detail. Okay, how all those things develop. The first name is constant. Another one is variable and placeholder. So if you look at here, constant basically just simply set like this, and then you're gonna import the TensorFlow STF. So this the rule you have to write. Whatever you just import TensorFlow STF. You can put as TF, A, B, C, D, whatever you need. But normally people use TF because it stands for TensorFlow. I think it's been accepted everybody using TF by standard. Not by rule, but everybody know that we're gonna have a TF. So whatever you want to use TensorFlow, you have put TF there. So let's go to the constant here. So TF here means TensorFlow. We're gonna assign A as a constant TensorFlow. So it is a variable called constant, and we're gonna set it into 3. So when you print this, basically, when you print A, they tell you the A is a tensor, and you got shape 1 there and got integer. Okay. All right. I think we can check this one. What does it mean there? And this is just, you don't run it yet. It's just you assign A as a constant. A is constant with 3, and the value is 3 there. Okay. And shape can be any shape here. So then if you want to run this, okay, seems that I think this one, because I'm using 1.13, okay, so it doesn't compatible then with 2.8. So what I need to do is I got error here. The error mean that it's not attribute session. So this is the old one. So to make my life simpler, I just install 1.13.1. No longer use this one. So what I need to do is I'm gonna install TensorFlow 1.13.1, so it suit to my program. Okay. All right. So let's hold for a while. So he gonna install the TensorFlow 1.13.1. Okay. Hopefully it works. Okay. Okay, I think we finished. Just restart runtime. Okay, since we are using the thing, just follow the instruction. And we're gonna import again TensorFlow STF, and we're gonna check what version now. It's supposed to be 1.13.1. Okay, now it's supposed to be okay. Now I got 1.13.1, which is as I expected. Okay, all right, and let's running this again. Okay, so it's the same thing. All right, so this is constant, now different a bit. Okay, now let's run this one. All right, now is A is equal to 3 because A is a constant 3, and J is A plus A, 6. Now, if you want to run A with TF session, TF station flow, access. So print A says run. Okay. So this is the way you run it. Okay. Remember that. Using TensorFlow, you got TF. You have to use TF session access. So says you dot run. So this is the code, the syntax. Says dot run and in bracket A. A is this one. If you print A, just simply like that. If you print says run A, it's gonna come out the result. Okay, so this is the way you run the thing. When you run, you have to use this. You have to use the word run. Says ss says dot run and the bracket. If you this is just a declaration. You declare A as a constant, and if you print A, it tell you A is a constant because it's a constant, and the shape is, in this case, can be many shape, and it is a type of integer. And if you want to run this, you need to use a tf session access, a syntax like this. So you can have says.run in bracket. So you are executing this code. Okay, another one. This is the same thing. You can declare. This is a declare. Just declare D as set a constant. Put in metric 1 by 3, 1, 2, 3, 4. And then again, you set E as a constant with this 2 by 4 metric. And F is a constant. You got 3 by 4 metric. And this is another, this is, I think, is 3 dimension, I think, this one. Okay, it's too many bracket. We couldn't see it, okay? Now, if you print this one, you're going to have D is a constant number 1. You got 4 constant here. And shape is 4. Okay, 1 by 4, okay? And the E, the shape is 2 by 4. This is 2 by 4. Okay, and F is 3 by 4. 3 by 4. Okay, F. So you got metric 3 by 4. So 3 by 4 metric, basically you can imagine like images, okay, with pixel. And G is a 2 by 2 by 4. So this is a 3-dimensional metric. And again, if you want to run this, you have to use session says and says run D, run E, run F, just simply like this, simple. Okay, and can get like this. Okay, D is 1 by 2 metric, so this is metric. Okay, F is 2 by 4 metric. This is 3 by 4. F is 3 by 4, and this is 2 by 2 by 4. Okay, so this is constant. And this is another one variable. This is a bit more important, variable. So the way you declare variable is the same. A as TF variable. Just now you TF constant. Now you put A equal to TF TensorFlow variable, and this bracket is the value of the what we're gonna assign the value to the variable A, and we're gonna set is a float 32, and you have to put this one initialize global variable. So this is considered global variable. This is I think the syntax. You just follow the syntax like this. Whatever you have variable, you just put like this. And this is to run it. Okay. So when you run it, A is supposed to be 0.3 because variable here you set 0.3. And okay, 0.3 now. Okay. And this one, the same thing, but normally people don't do this. You got weight, isn't it? So basically this is for weight. Okay. This is for weight. And variable usually is for weight. You assign the weight with numbers. Let's say this A is a weight. So your weight you assign 0.3. You assign yourself. But normally in deep learning, you assign D is a weight or bias. Let's assign by random. Okay, you're gonna put random number to this. So you don't have to put manually because we have so many weight, in the deep learning neural network. So let's the system assign the weight randomly by itself. So you have declared D. D is a variable, and we're going to assign the value of D variable by random. Okay, any number by computer. Then this is the syntax you have to follow. Just write down. Then when you run it, you just the same thing with tf session access and says run init. Okay, says run init and print says run D. Press D. So if you put here, now the D has been assigned to 0.8 as random assign. Okay, if you run it again, this is 0.8 and be assigned by random number. Here you assign it manually, but here you assign D or we used to be weights by random number. Okay, 0.8. And if you run it back again, you're gonna have a different value, and then you're gonna put another random. If you run it again, so we're gonna put another value, a negative and positive. Okay, that's because the random number we can't control because we set it random. Okay, and this is the same basically. Okay, if you repeat the code, find the D is now being assigned to different random value. Okay, now negative. All right, now if we set another one again, you're gonna have 0.2. So a different value. Each time you run this, D will be assigned to different value. Okay, so this purposely we use this for declaring the weight. Remember, when the weight is when you do the propagation, forward, backward during the optimizer running. Then when you moving backward, when you moving forward, they're gonna send a new weight. The purpose of assigning the new weight simply because we want to have a loss to 0. Remember that? Okay, so this is the purpose of variable. And placeholder. So placeholder is a place for input to sit. Okay. All right, just look at this. X, we're going to declare is a placeholder. A, we're going to declare it as a variable. And now we put it manually, 0.3. All right, 0.3. So let's say we have this. Okay, added X times A. When you run it, X, when you run it, so now you got X is a placeholder. A is a variable 0.3. Okay, so when you add this, you're going to put 0. A is 0.3 times X. And what is X? X is a placeholder. So you can have X, you can put 0.5 here. You can put other numbers. So it is a placeholder for this number to sit. And this placeholder basically is regarding with data set. You put all your data set here. They're gonna sit here one by one. The first input, the second input, the third input, the fourth input, the fifth input, sixth. So you declare it's a placeholder. It's a place. It's a place for the data set to sit in and run. And then for the next round, takes another data, sit in the X and run. Then for the third data, put in the X and run. While A is variable, we assign manually 0/3. So if you run this, basically you got 115. So 0.3 times 0.5. Okay, so every time X will be new. So in this case, X we assign to 0.5. You can assign any number here. Now, let's say we have this. Okay, SWX plus B. Okay, so we have this formula. And if you recall, this is W is a weight. Imagine W is a weight. Imagine this is a weight and this is a bias. Okay, remember this one? Okay, remember you got another weight here. Remember, so you got there. Remember? and so on until the end. So you got weight here, and you got bias here, and you got X input here. This is X, okay? So Fs is equal to W times X plus B, okay? So you're going to get S equal to, okay? All right. If you got here, so S will be WX plus X, this one, and then you kurungan plus B. Okay, last is plus B. So this is a summation. WX plus B plus, and then you got plus B. So this is the formula. Now, if we go back to here, all right, so we got X plus B. So W is a weight, B is a bias, and X is a input data. So you're going to have like this. You're going to set weight now 0.3 and bias is negative 0.3. So you set it manual. So when you run, so this is a very simple, so you got 0.0, okay? And X1 is, you assign 1 to X. Assign 1 to X. So X is equal to 1. And then 1 times W 0.3 plus 0. Minus 0.3, so you got 0. Okay? And this, you just setting it. And this, you run it. Okay? Remember, look at this. This, you set it, want it to do. Then here you run it. So this is you run it. Run this one. S. You run S, where X is the placeholder, you assign 1 to X. And then it follow this one. Alright, now, we're moving to this one. Okay, after you know, so the important here is the variable. The variable is for weight and bias. Okay, so this normally for weight and bias. Okay, all right. And placeholder basically is for place for dataset to sit and proceed to run. Is sit ready to execute run. Okay, all right. All right, okay. Okay, so for dataset to sit and ready to execute to run. And this is for the weight and bias normally. Okay, let's look on this. Now we moving to XOR using TensorFlow. Now we are develop the XOR using neural network with TensorFlow. So let's back to this one. Okay, now if you look here, okay, we're going to import the data set. The first thing you need is, this is the data set. Okay, the input data 0, 0, 0, 1, 1, 0, and 1. And this is the label. Output data is a label. So this consider 0, 0 and 1 is 1, 1 and 0 is 1, and 1 and 1 is 0. And you need to have a placeholder. Okay, so we're going to have a placeholder shape. Since we got 2, okay, so something none by 2 metric. So none here can be 1. In this case, 1. So you have to have a placeholder to hold 2 numbers, 2 input. Your input, 2 input. Okay, you got 2 input. You have to get the place for 2 input to sit down. So you got 1 by 2 metric. Okay. And you got the output label, and you have 1 label. So you need 1 by 1 metric here. Okay, for the label to sit down. Okay, All right. So in this case, number 5 can have like this. Hidden node is number 5. Okay, let's look on this. Okay, you're gonna have all right. Just let me thing here. Okay, so I'm gonna put this, put it there. Okay, and let's run it. Okay, so these are setting. You setting the input data is set as a data set, and output data is you set as a label. And then you need to create a placeholder. Okay, so placeholder for the data set and the label to sit down. Okay, so here the same thing, you're gonna have a placeholder. None is, in this case, is 1 by 2. You got to input. And the label is you got 1, so you got 1 by 1 to make the label sit inside there. Then you run. Means that you have declared this, you setting this, you're not running yet. We're gonna setting it up. We're gonna set everything complete, then we run later on. And we're gonna have 5 hidden nodes here. So okay, I'm gonna put this and I'm gonna run it 1 by 1. And okay, now we set the hidden node by 5. Okay, now this is bias. B is a bias. Okay, bias, I put it hidden because normally we call it hidden layer. When it is hidden, it's bias, hidden. Okay, you can name any name. You can call it bias or whatever. So we're gonna have a B hit bias. Bias. How many bias we got here then? We got this is one bias. Okay, so this you got 5 nodes. So you got 1 bias, B1, B2, B3, B4, and B5 below there. So you got 5 bias. Okay, and normally output we don't put bias. Okay, and then we declare the bias is variable, so let's random number assign to it, because you're gonna dealing with a million of bias. Okay, in the here you got 5 nodes. If you got 10,000 nodes, you're gonna set 10,000 bias. So let the system assign it. Hidden node is 5. Okay, since just now you got 5 hidden nodes. Now we set bias. Now the weight also declare as a variable, and we assign the weight value by random number. Let's computer do it. And how many bias do we have? 2 times hidden nodes 5. 2 times 5 is 10. So we're gonna have 10 weight. Okay, so let's see this one. So what we're gonna have now is how many weight we're gonna have. Okay, so we're gonna have this, 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 and this. So WX FS is WX plus KS is WX plus WX plus weight. This one plus weight and plus B. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So you got weight every here. Weight 1, weight number 2, weight number 3, weight number 4, weight number 5, and so on until weight number 10. So you got 10 weight here altogether. You got 10 weight. Okay, and you got 5 bias. See, when you're moving forward and backward, they're gonna change weight and bias. to adjust the target value. Now, so you're going to have 10 weight here, 2 times hidden nodes. So remember this. You don't have to worry about how many weight you're going to create. You just put, this is the input. We got 2 input. Okay, we got 2 input. And we got the first layer 5 node. They're gonna run it. The code will know that this is 2 times 5, 10. So we have declare weight 10 weight. So let it run. Okay, so green mean okay, no error. So now the weight has been set 10 weight, bias has been set 5 bias, and placeholder for label is there, placeholder for the data set is there. Now we're gonna run it then. Let's see what's next. Now this is again, okay, the summation. Okay, so this is look at the formula there. Okay, look at the formula. And we're going to use sigmoid. So an input, so this is WX plus B, you know. So input is, this is X, this is W plus B. So WX plus B. And you have multiply, okay, because we got because you have summation product, okay, you have this and this. Okay, so this is W1 and this is W2. Okay, and this is X1 and this is X2. Okay, and this is B. Okay, so S basically will be S this one. Okay, basically is X1 times W1 plus X2 times W2 and all together plus B 1 plus B. Okay, all right, so this is for this only. So okay, remember this. Okay, and so the same thing here. So this is what it called. So sigmoid basically Fs. The result of S, you just put sigmoid. Okay. So this is, we use sigmoid here. In this case, we use sigmoid. So you got CF mat multiplication and put WF plus B hidden. Okay. So we're gonna set the formula like this. All right. So it's green, no error. Then the next step basically is let's say go for the output. Okay. Go for the output. Code. Okay, so let's see this one. Now we are moving here already. All right, so this is the thing, okay? All right, so are we moving here now? So here, how many weight? 1, 2, 3, 4, 5. So basically, number of weight, 5 times 1. So you got 5 weights. So how many bias? 1 bias, B here, bias. Since this is the output, we normally don't put bias. All right, so we are moving to output now. So so the output, this is the output. So you got weight for the output. You got hidden node plus times 1. So hidden node you got 5. Got 5 here. 1, 2, 3, 4, 5. And The next layer is one node. The next layer is one node. So you got 5 times 1. So this mean that you're gonna setting 5 weight, and we don't have bias, so just don't worry about bias. And the output basically again we use sigmoid, hidden, and the output. Okay, so W plus WX only. We don't put plus B like this, plus B hidden, because at the end output no bias. So here we got no bias. Here you got bias. Here you got no bias. If you want to put bias, okay, no problem. Okay, still work. Okay, if you want to, you can try later on. If you put bias and you don't put bias, how's the accuracy? You can simply test that, no problem. And so this is the output. So remember, this is the output. Okay, and the output, remember, this is supposed to be relate to the loss. Okay, and this we'll run it first. Right, no problem. Okay, everything is okay. No syntax error. And this is about, okay, just put all together. Okay. All right. Put all together. And next will be, all right. So, all right. Remember this? The target value at the label minus target value. Remember? When we're declaring the loss, we're going to look at the target value minus the output. Okay, the target value minus the output. Okay, and we square it simply because the thing is to make easy calculation. Okay, and you just name it cross entropy. Okay, you can name it any other thing. And this style is what we call cross entropy. So to make easier, you call it cross entropy. Send the loss. So you're gonna set the loss. How is the loss? The loss is we're gonna take the average basically. Cross entropy. So this is the label minus target value minus fx sfx. Okay, this one. Okay, remember this one. Target value minus fs. Okay, target value minus fs. Fs is the output. Okay, fs is the output. So in this case, if you look at this, output is this one. Okay, the end of the output layer. Okay, so the result of you deduct this one between two gonna be the loss. Okay, so the target now is to minimize the loss. So you're gonna use optimizer back and forward. So in this case, we use Adam optimizer, and we have a learning rate 0.01. So remember this one. So optimizer 0.01 is the rate of changing the weight and bias. So this is the value, the rate that how fast you're gonna change the weight and the bias. Weight and bias, this one. So this is bias, and this is weight. And the bias, you got 5 bias. Weight, you got 10 plus 5 here. Okay, 15 weight. So the optimizer, where is it? So the optimizer basically just back and forward, changing the weight and bias with this rate. And it is slowly. You're going to change it slowly from 0.3, 0.04. You can change this value. It depends, okay? And so this is during the train. We're going to use the optimizer, minimize the loss, okay? So when you have optimizer setting like this, okay, you set the optimizer like this. You're gonna use Adam optimizer with 0.01 learning rate. Then you're gonna run it. Optimizer, minimize the loss. Minimize the loss. So you're gonna keep doing this until loss is 0. Okay. Now we run this one. Okay, no problem. Okay, I think you follow. And now I think we finish setting. Okay, now we're gonna run it. Okay, we're gonna run it. So this is training. This is training. Okay, now I think we have set all we have designed the neural network. Okay, we have designed the neural network like this. I think everything is declared now. We got 6 bias, 15 weight, and optimizer. I choose Adam optimizer. The first layer, we use it softmax. You can put value, okay, whatever it is, okay. And for the output, you got softmax. So this is supposed to be value, but we use softmax, okay. And okay, next, and this is about just now I said bias and weight, okay, hidden nodes and so on. And this is about reducing loss. I have explained you just now. And so this is how you're gonna run the later on back propagation. And okay, let's run it. Okay, so this is the same code here. Okay, but basically what you're gonna have here, right? All right, when we run it, as usual, we're gonna use TF session. Okay, ses equal to TF session, run init. Okay, init run. Then for epochs so this is the epoch. Okay, we're gonna set it until 2001 epoch. I think we're gonna set this. You can change this number. So we're gonna run this one. We're gonna run now. We're gonna train. In other words, when we run, we're gonna execute this because we have set this. We're gonna execute this. We're gonna use train. Train is this one. We're gonna use optimizer, minimizing the loss, and the loss will be this, reducing mean cross entropy. Cross entropy will be this. It's basically target value, label minus target value, and the output basically is this one, the last output, and output. This is a label. So where is the label basically? So label basically you set this and output. So got placeholder to place this output data there later on. And follow. I hope you follow. So this is how you train. Train, loss. Just this is the syntax. You put train, loss, weight, bias, weight at the output layer, and fit dictionary. So fit, okay. Since you got input, you have placeholder just now. Okay, you have an input is a placeholder for the input data. So remember this. This is input data is a data set, and input is a placeholder for data set input data. So what you're gonna see here basically, where is it? Okay, you're gonna have input data move to the placeholder and input, and the output label data we're gonna put in the placeholder name and output. And output is a placeholder. Okay, and output is a placeholder. Let's look above. And output is a placeholder to store label output data. So label is output data. So you have, and output is a placeholder for the input data to sit in. And input is a placeholder to make the data set sit in. Okay. And so this epoch you get 2001. In this case, I put every 200 print. What is the C value here? Okay. So it's supposed to be, C value is supposed to be 0 here because we need to have a loss until 0. Okay. Let's run this. What's it gonna have? All right, now they run it. Okay, so the first 200, the loss is 0.2. The second 200, the loss now is minimized to 0.1. The 400, 0.4 until the end, until 2000, the loss is 0.0. This is good enough. You have loss 0 now. When you get loss 0, mean I think it's success then. I think we can say that the model is trained already. He learned enough. All right, he learned enough. Then this is train. You train the model that you design here. So these all are the model that you design, everything. And this is where you run the model until how many epoch you got. And just put some printing here just to allow us to see what happened. Okay. And then the train is finished and the loss is 0.0. I can say that it is good. It is well trained. Fully is 100% accurate. Now let's test it, whether it is accurate or not, whether it is can make a prediction or not. Okay, so this is the simplest way I do the testing. Okay, and let's see what this is all about. This is only I'll print. Okay, so I'm gonna put the input data. Input data is a data set number 0, data set second, data set third, and data set fourth. Because we have 4 data set here, 0, 0, 0, 1, 1, 0, and 1, 1. Input data is a data set. Output data is a label. But in testing, we don't tell them the label. In here, in training, we tell them this is the data set and this is the label. You do the epoch until loss is 0. When it's 0, I can say is sufficient train. Let's test. When you test, you just give the data set without the output. Okay, so you're gonna put the input data number 1 data set, says run output, and then the placeholder and input, put the data number first data, and we don't tell the output here. Let it predict. Okay, and the rest is the same. Okay, so testing basically you run what you have trained here. You run without telling them what is the output. Let it predict what is the output here. That's what we call testing here. So this is the testing. So when you run it, so you can say the input 0, 0, the output will 0.01. So mean that it is 0. Okay, just let's check. Okay, let's check with the. Okay, this one. 0 and 0, the output will be 0. Let's see. 0 and 0, the output will be 0. I think it's okay because 0.01 means 0. 0 and 1, the output will be 0.9, mean it is 1. Okay, 0.9 mean it is 1. So let's see. 0 and 1. 0 and 1, you got 1. Okay, it predict good. Okay, it predict good. And the third one, 1 and 0, it predict 0.9, mean 1. Okay, almost 1. So it predict 1. 1 and 0. So 1 and 0, you predict 1. Okay, good. It predict right. And the last one is 1 and 1, they predict 0.16. So it means 0. Okay. So, okay, that's right. So that's mean I can say it's 100% accurate. Okay. All right. So you can just go on and on testing the thing. Okay. The first one. Okay. All right. So you're gonna 1 1 is 0. Okay. 1 1 1 and 0. 1 1 is 0.16. Okay, that's just okay. So it again right. So you can keep go on testing and so on. Okay, all right. And so this input data number 3, data set number 3. So no, it's supposed to be 0. It's supposed to be 0 here. Okay. All right. You printing the wrong thing and okay. All right. You run it again. 0, 0 is 0. Okay. So the first data is 0. Let's see. The first data is 0, 0. And the output will be 0. Okay. The output data will be 0. Okay. So this is the input data set 0 and 0. Input this one. So this input, this one refer to this one. And the output here, this is refer to ses run output. Okay. And ses run output is there basically. See, the output is basically you run this one. Okay, when you run this one, it just go back, sigmoid, w out, and so on, and trace back. Okay, so he run the output. Okay, because here you have train. When you train, you have weight and bias already set. Okay, can list down all the weight and bias basically here, because we got 10 we got 15 weight can print here. Got 2 times 5 is 10 weight. You can print it. I'll check it out. How do you print this weight? We're gonna list the final weight. So when you finish this, okay, bias and weight has a final value. Okay, that's final value, weight and bias. Make it the loss is 0. Then you can save it the train. You can save it this one. When you save it, mean that you can use it to predict anything. And this has been trained, so you save it. After it been trained, the final value and the final bias is gonna be saved. So you can bring it the model everywhere, pass email there, because the weight is the model has been trained. Now in here, basically you can let's say if I put 3000 here, okay. Let's run it more. And what's happened to the training? Okay. So I just make the epoch 3000, okay, bigger. So let's see. All right, the weight, the 2000 is 0.0038, but when I do more epoch until 3000, it's become better, 0.0114. So 2000 is 0.038. Okay, see, 0.00014. This is 0.038, so it's bit better. Okay, you run it again. 3000. So far so good. So I put 4000. Okay, make it bigger, train. Now we're gonna train it until 4000. Let's look and oh, see, after 2016, it become something wrong here. There, you see. So you cannot run it forever. Now the best is 2014 here. When you got 2016, it become 6. Okay, so if you train this one, if you do this, let's say we do this, testing this, the output is 0, 0, still okay, but it is the loss is become number. Okay, I think you better stop at 3000 just now. I think better stop here. Okay, better stop at this one. So 3000 plus 2400. Okay, we have to stop this one. So we know we can stop here because the loss now become bigger now and it become chaos. So this thing to overtrain, okay? The weight and bias become not predicted, not finding the right value, because if it's already zero, then you keep running it, and the learning rate is gonna change something, and then it mess up again, okay? So this is the way you do it, okay? To be we stop